Hey everyone, and welcome back to the two-port MIMO HFSS setup. The last time around, we ran a bunch of sweeps, and now that that sweep has completed, we're going to go through the results real quick. So we have a bunch of S1 to, these graphs that are here. And of course, you get to select which one's, the best in your case. I'll just quickly show you the gain as well. A very unique graph. But what I'll do is, because we have the highest gain here, which is if you see the highlighted text here says it is for move equal to 65 mm and y equal to 145. So if we are to visualize that, all we have to do is put in those values. So we're looking at 145 and 65. If we hit apply, so this is how things would look, where we have the max gain. And similarly, if we are to check the results for exactly the one that we are looking for, we're going to go ahead and click on modify report, come to families, and now we're going to select 145. So that's right there, and we're going to select 65 and we're going to hit apply. Well, that did not do anything. Usually it should. So what I'll do is I'll quickly go ahead and delete all this, and then we'll modify report again. Oh, that's what happened. Okay, so we go back to 145. Sometimes these things can happen where things don't show up, and that's okay. And 65 right there, right, new report. And so we got the S11 for it. Now what we'll do is we'll quickly also add the S12 and S22. And so this is what it looks like. Since your S11 and S22 are fairly overlapping, and the isolation is also pretty good, like it's touching, I guess it is somewhere around minus 20ish. Let's see, let's add an X marker and go to 2.4. Cancel this. All right, so around minus 20.13, which is fantastic. And also the fact that you have just enough return loss of around minus 10.4 and minus 10.7, so it is serving the purpose. But when you deal with MIMO, you also have to deal with certain other parameters that are involved. When you talk about MIMO, you deal with ECC, you deal with DG, you deal with TARC, and you deal with CCL. Now, what are these four components that I just said? Now, ECC stands for envelope correlation coefficient. Okay, this is basically, I mean, I'm not going to get into the definitions of things, but in short, ECC should be as close to 0 as possible, because ECC basically tells you about the correlation between the two antennas. So if the two antennas that are there are transmitting the exact same signal, it is defeating the purpose. Okay, you have different antennas on your screen right now. This is one patch, this is the other one. Both of them doing the same exact task does not really work for us. Sorry for that. So what you do is you need to ensure that ECC is as close to 0 as possible. That shows that both of these guys are independent. Now, for us to calculate ECC, it's not direct. We need to actually put in the equation on our own into HFSS and then get the output. Now, second thing is DG, which is diversity gain. Diversity gain is basically how much better the MIMO antenna system actually performs compared to the single isolated antenna. Okay, so this is basically also calculated from your ECC. So these guys are sort of inversely related. So if DG is going up, that means your ECC is going down, and vice versa. So if your ECC is up, DG is obviously going down. Theoretically speaking, DG should be 10 dB. That's when you're like, great job, you've done an amazing work. If you get anywhere close to 10 dB. If not, keep your DG greater than 9.5 dB or as close to 10 dB as possible across your operating frequency or operating band. Okay, that's about DG. So both of these guys are sort of related to the same thing. You calculate ECC, you get to calculate your DG as well. Now let's talk about total active reflection coefficient. Okay, and now this is something that is related with the traditional Has parameters, and like you assume like, okay, one port is excited at a time and then things happen. Great. What is TARC? It is basically the ratio of the total reflected power to the total incident power. Now, ideally, you would want to see it as close to S11 as possible. Okay, and again, this is something that we will also calculate using equations, not directly possible in HFSS. And last is your CCL, which is channel capacity loss. Now, this is something that would sort of characterize the upper limit of your transmission rate reduction caused by correlation and multiport coupling. What I mean by that is basically, so if your antennas are placed close together, like in our earlier cases when we were running the sweep, because there was electromagnetic coupling, there was losses that would degrade your data carrying capacity, because obviously if there is a lot of coupling happening, there will be losses means your data rates would reduce, right? Yeah, obviously you ultimately want to do something with your antennas. So CCL will quantify this penalty in bits per second per hertz, so bps per hertz. Now ideally what would you want to see? You would want a CCL that is, less than 0.4 bps per hertz, right? Less than 0.4 bits per second per hertz. Okay, so that again, we're going to go into the calculations of that. So to start off, let's talk about ECC. Okay, so what we need to do is we need to put in the equation. So what we'll do is we click on results and right click, and what you will see is output variables. That's where we want to go. Okay, and now we need to place a name, so I'm just going to type ECC. Okay, and now we need to put an expression. Now this expression that is there, I will be pasting in the description box so that you can get it too. But this is basically the equation that you would see on multiple research papers or any other reference material that you would use. Okay, this is just converted into something that is more friendly for HFSS. Okay, and then all we have to do is hit done. And now right click again and go to output variables, and hopefully we can see that. Okay, first of all, let's go ahead to rectangular plot. And now what we're going to do is, since we already put in the output variables, it should show up here. So I assume it did not get saved. We'll go back to output variables, type in ECC again. Oh, I don't think I hit add. Yeah, that's what happened. All right, always hit add. Rookie mistake right there. Anyways, let's go to create model, solution data report, rectangular plot. Now we go to output variables, ECC is right there. We don't need a function, and now new report. And because we ran a sweep, you're going to get a lot of results, which we do not really have to worry of. We just have to go back to families, click on the one that we are looking for. That is 145 mm, and the other one is I think 65. Right, hit apply. There you go. Now what we'll quickly check up is where exactly is it when we are at 2.4. Do you see what I mean? We are we are as close to 0 as possible according to HFSS. In fact, we are at 0, but I'm surprised it is at 0. You do see like there is some sort of value that comes up. So you could always take like 0.002, for example. Okay, just in case you want values to be put up. But as per the marker, it's saying 0.000. Okay, fine. Let's go back to output variables and let's actually start dealing with DG. Now, DG, what we need to do is we need to put in the next expression, which is 10 times 1 minus ECC, the ECC squared, the whole thing raised to 0.5, or it is basically the square root of this term. We're going to add that and we're going to say done. Similarly, we're going to come back and rectangular plot, output variable, DG, and for families, I'll select it right away because I don't want a big sweep to come there. 145 and 65. And new report. There we go. We have something. Let's check where it stands for 2.4. It is saying 10. All right. But again, if you actually zoom in, it's somewhere around 9.99998. Okay, so take these results with a grain of salt is what I would suggest. But you're getting the plots for DG and for ECC. Now, same thing we're going to do for TARC and CCL as well. So again, we go to output variables and we're going to see TARC, and I'm going to put in the equation. Add this, and for the next one, CCL as well, what I'll do is I'll quickly add those equations in. I don't want to keep coming back to this. So CCL, and copy this. So something's not worked out. Let's see. It should be blue. When it's blue, then you can actually be, satisfied that okay, things are proper. Okay, so I've added all the output variables. Now just we need to plot these guys. So come back, families. First of all, select what you want. So in our case, we need TARC, and then come back, come to 145. So this process remains the same. You just have to keep doing it. And then I hope you've selected. Yep. Right. So this is very much similar to what you would see in our S11. Right. So in this case, of course, you're going to be like, okay, what exactly is this guy showing me? But if you were to plot just the S11, right, and family would be just that 145 and 65, you're going to notice something, and that would be, have a look at these two graphs. Like, how similar is it to S11 is my question to you. Right. So again, take the marker just in case you're not satisfied with what I'm showing. Then 0.33 is what it's saying. So you could take these values in as well. Not a problem. Or you could, I think most research papers would also say close to S11. Okay, that's also something that I've seen. Last but not the least, we also go ahead and get our CCL families. We're going to select 145 and 65. Right, and this should something happen. Oh, CCL would, okay, makes sense. All right, so a couple of things that you need to understand when we are dealing with let's say the last one, that is CCL, is that CCL in HFSS would require you to compute the complex conjugate of an S parameter, right? And when you do that, HFSS treats the S parameter as a complex number but gets confused about the formatting. So the equation that we put earlier, which was right here, the early one was not working. There was an error showing up, as you saw. So I've added this revised equation. Now it's a pretty big equation, but it needs to be done so that we can break the S parameters into their real terms and the imaginary terms, right? If you see RE, real terms, and the imaginary terms. Now we're going to say done, right? And let's go ahead and go to results. The same process once again, families, we're going to select the 145 and the 65 one. And that should, now we should select the CCL as well. A new report. Got some sort of a graph for sure. Let's see what it means. All right, and we know what it means in terms of bits per second per hertz. So you're getting somewhere around 0.29. As I previously said, what should it be below? The limit that should be set for CCL when you talk about bits per second should be less than 0.4 technically. We have it somewhere around 0.29, which means we are like fine, right? So this is the way in which you go ahead and plot the results that are related to MIMO. Now this will apply for 4-port as we go on with it. All right, so keep in mind, this is just for the 2-port MIMO setup. Now, when you deal with ECC in terms of 4-port, then you'll have to deal with ECC 1, 2. As of now, we have done that. We've done ECC 1, 2. And how I can tell you that is because if you check the equation, we're dealing with S11, S12 only. Eventually, you're going to have 4 ports, like 4 patches and 4 ports. And so that means you will have S11, S22, S33, S44. And so that means you will have ECC 1, 2, ECC 2, 3, ECC, so like, they will be with respect to each other. So there will be more calculations involved there. Similarly, you will have DG calculations. You will have TARC and CCL for each case. Okay, so that also will be calculated, but all of these are calculated using output variables, wherein you have to put in an equation. I will be putting these down in the description box, so you can directly take it from there when you're dealing with 2-port MIMO setup. When you're dealing with 4-port, of course, we'll deal with that in the next or maybe 2 videos down the line. So that is when you can take it up from there. So with that said, these were the important MIMO terms that were required for you to go ahead and actually understand whether or not your MIMO setup was good or not. In our case, we had near perfect results, so that's fine because it's a simple setup. In your case, maybe your results are, or your antenna is such that it is quite complex, so that is where your ECC could vary, your DG could vary, and all of these could vary, right? So at the end of the day, you need good results, otherwise your project is not going to go through, right? So with that being said, I think that should cover your 2-port MIMO. We are done with the 2-port MIMO sweeps. I think in the next one, we can actually get started with the 4-port MIMO, unless something else comes up in my mind. But as of now, I don't see anything else coming up. So with that being said, this should be marking the end of the 2-port MIMO, and see you in the next one.